Number 9, the figure above shows that the graph of f prime on the closed interval -1 to 5, f prime has horizontal tangents at 1 and 3. The function f is twice differentiable with f of 2 equals 6. Part A, this actually, I like this part. It's pretty easy. This one's easy. Find the x-coordinates for each of the points of inflection of the graph of f. How do you have a point of inflection on f? When f changes concavity, or when f double prime changes signs, or when f prime changes direction. I'm given f prime, so I'm looking for when it changes direction. So we'd say points of inflection occur when x equals what? 1 and 3. I'm going to do this, though. How do I write this? F has a point of inflection when x equals 1, since why? Since f prime changes from increasing to decreasing. Now, the reason I broke it up is because it's kind of two different justifications. It would be better to break it up than to say, or vice versa. So you could also say, and when x equals 3, since f prime changes from decreasing to increasing. You guys okay with that? Pretty easy, right? So 2 points. You're going to get 1 for the correct answers and 1 for the correct justifications. If you just say when x equals 1 and say f prime changes from increasing to decreasing, that's 0 points, even though you did half of it. Because you have to show you get 1 point for both answers, 1 point for both justifications. Any questions on that one? Okay. Part B. At what value of x does f attain its absolute minimum? This is an interesting problem. How do you find an absolute minimum? Okay. When f prime changes signs from what to what? From negative to positive. When f prime changes from negative to positive. But that's not an absolute minimum. That's only a local or relative minimum. So the first thing I'm going to do is I'm going to say, I'm going to set f prime equal to 0. So when does f prime equal 0? When x equals 1 and 4. Then I'm going to do a number line with endpoints of -1. You're right. I'm just talking about critical points right now. Okay. So 1 and 4. So this is when f prime is 0. These are at the endpoints. So now, what is the sign from -1 to 1? It's negative. What's the sign from 1 to 4? Negative. What's the sign from 4 to 5? Positive. So we would say relative min when x equals 4, since f prime changes from negative to positive. But is that the absolute minimum? No. So that's not going to get you the point. We want the absolute minimum. So what are the other points that I have to consider? So we're going to say consider, I guess you could say consider when x equals -1, 4, and 5. What is -1? Is it a max or a min? It's a max. And 5? So the best justification is this, okay? This is what you're going to say. I'm just going to finish this up right now, actually. F has an absolute minimum when x equals 4 since f prime of x is less than or equal to 0 for negative 1 is less than or equal to x is less than or equal to 4, and f prime of x is greater than or equal to 0 for 4 is less than or equal to x is less than or equal to 5. All right, so for part C, we want the tangent line. So for the tangent line of G, we need to know what G prime of 2 is. We need to know what G of 2 is. So first we have to take the derivative of G. So G prime of x equals, that's going to be product rule. So 1 times f of x plus f prime of x times x. So G prime of 2 is 1 times f of 2 plus f prime of 2 times 2. So G prime of 2 equals f of 2 was given to us. It said 6, so it's going to be 1 times 6 plus f prime of 2 is negative 1 times 2. G prime of 2 is 6 minus 2, which is 4. Yeah, you are. G of 2 is 2 times f of 2, which is 2 times 6, which is 12. So my tangent line will be y minus 12 equals 4 times x minus 2. And that's that.